Okay. Is there anything very quickly on the homework from last night? No? We feel pretty good about it? Basically simplify it, get it down to something that you can graph quickly, and then you gotta remember that you had undefined values where you have points of discontinuity. Okay, so let's take a look at this. We're dealing with rational equations. But if you look at the graph of this one, does this look like the stuff we did last night? No, right? This has got two pieces. You got a piece over here and you got a piece over there, all right? However, it's a rational expression, right? Where would this be undefined? X equals 3. Right? That's where x minus 3 is equal to 0. However, last night, where you found something was undefined, right? That was a point of discontinuity. Is that the case today? No, it does not, right? So, however, at 3, do you actually have an answer? No, they're telling you there's no answer. So how do we see that on the graph? Yeah, there's like a space. So at x equals 3, which is a line that looks like that, right? The graph is never going to hit that spot because we know there's no solution there. Okay, so there's definitely not a solution there. This is like an imaginary line. And what happens is the graph over here approaches it and gets infinitely close, but never actually touches it. And up here, the graph would continue up and it would get infinitely close, but never actually touch it. You know, that's a hard concept to understand, right? Theoretically speaking. So theoretically speaking, if I said I'm going to take half of whatever this distance is from me to the wall, if I'm going to take half the distance, I take a step that is half the distance, right? I take half the distance, so now I'm standing here. I take half the distance, I'm now standing here. I take half the distance, I'm now standing here. If I could physically keep taking half the distance, would I actually ever touch the wall? No. Theoretically, I'd never actually get to the wall if I could continue to take half the distance. I just physically can't do that. Correct? So that's the concept here. You're going to get infinitely close, but you're actually never going to touch that line. That line has a name. It's called an asymptote. Okay. So where something is undefined, you know it'll never have a solution. But depending on the rational equation that you're given, it might be a point of discontinuity. It might be an asymptote. So how do I know the difference? What was different about the stuff we did last night?
It was a linear.
When you...
When you...
wasn't linear to start with.
No, you balanced it.
Once you simplified it, it was linear, right? Or it was a quadratic, the one we did, right? So the difference here is if I go to try to simplify this, is it even possible for me to simplify it? No. Last night, every time we went to simplify, everything on the bottom canceled out, correct? Are you guys with me? Okay. So in this case, if you can't simplify it, if you're going to be left with that piece on the bottom, then you're going to end up with an asymptote. Okay, not a point of discontinuity. All right, if you looked at this graph, does it look like there's an asymptote? Yes, where? You're looking at it. Looks like it's -4. Does that get backed up by your algebraic? Yes, right? Now, when you say you have a vertical asymptote, like your axis of symmetry or anything else, it is a line. So you're not going to tell me you have a vertical asymptote of -4. Because it's a line. So it needs to be an equation of a line. So it's always going to be x equals. All right, -4. Are we good to there? So this is your vertical asymptote. And here, if you're looking at the graph, does it look like they have a vertical asymptote? Maybe 2, right? What do you got here? It looks like maybe if I went here, it would approach coming in this direction, it would approach coming in that direction. It doesn't have to approach in both, but it does. And where else? Maybe right there. It looks like at 1 and -1. Now, could we back that up algebraically? What do? We look for where this is undefined, right? Could we factor x squared minus 1? That goes in dots, right? X minus 1, x plus 1. So you have two spots where this rational equation is undefined. And those are your two vertical asymptotes. Yep. We're going to talk about that in 1 second. All right, are we set there what we're looking for in our graph? Okay, so when you look at these graphs, this is what Calvin's bringing up, is there a line horizontally that these look like they approach? How about this one? Where do you think it horizontally might be approaching? Imaginary line might be approaching. Maybe 2. Looks like it's definitely possible this could keep going this way. This could keep going this way. And it's only close to possibly 2. How about this? 0. Looks like it could be y equals 0. How about this one? Well, this piece of the graph down here doesn't look like it's approaching anything horizontally, correct? But what about this piece? If you look at this piece over here, does it look like it's approaching anything? Probably what? 0? Does this side also look like it's approaching 0? Yeah, so I'd say probably this. Just based off the graph. Now, are you going to be able to tell if it's like y equals 1/3? No, not graphically. Okay, so we need to take a look at things algebraically. So there's some rules here that you need to learn. Your vertical asymptote we've already covered. Take a look and see where it's undefined, right? So when they're talking a of x and b of x, they're talking about a of x being the numerator and b of x being the denominator. So when b of x is equal to 0, whatever x values make b of x equal to 0, as long as they don't cancel out, right? As long as there's no common factors like we had last night, then those end up being vertical asymptotes. You okay there? All right, what are your rules to find horizontal asymptotes? So you need to look at the degrees. What do we remember about degree? Polynomial equations. We did a whole unit on polynomials. What was a degree? What is it? Nope, not multiplicity. Nope, not every time. Highest exponent in your equation. Highest exponent. If you put it in standard form, it would be in the first spot, right? Highest exponent. So you look at the degrees of the top and the degree of the bottom. If the degree of the top is larger than the degree of the bottom, you have no horizontal asymptote. Okay, so you have to memorize this. If the degree of the top is less than the degree of the bottom, so the degree of the bottom is bigger, then you will have a horizontal asymptote at 0, y equals 0. If the degrees are the same, the top and the bottom have the same degree, then you look at the lead coefficient of the top and the bottom, and that will be where your horizontal asymptote is. All right, so let's go back up here and look at what we're talking about here. We looked at this one and we thought that it was going to be at y equals 2, looking at the graph. Okay, so we should be able to look at this and follow our rules. What is the degree of the top? Highest exponent, 1, right? So degree is 1. What's the degree of the bottom? Highest exponent, 1. So down below, what does it say? If the degree of the top is equal to the degree of the bottom, where do I look? Lead coefficient. Look at your lead coefficient. What's the lead coefficient of the top? 2. What's the lead coefficient of the bottom? 1. So y equals 2 over 1, or y equals 2 will be your horizontal asymptote. This is what we got, looking at the graph. That's what we thought, looking at the graph. If this was 2, x plus 1 over 5, x minus 3, where would my horizontal asymptote be? 2/5. Are you with me there? Okay. How about this one? What's the degree of the top? Nope. 0. Right? Degree is 0. It's x to the 0 power, if it's not there. And what's the degree of the bottom? 1. So the degree of the top is smaller than the degree of the bottom, then what do we get? We get a horizontal asymptote. Yes, look down to that's your second one. So if this is smaller than that one, right? Or what is 0 over 1? 0, right? Okay. So this would be, well, there's not would be 0. So y equals 0 would be your horizontal asymptote. This is what we thought, looking at the graph. And this one, same thing. What's the degree of the top? 0. What's the degree of the bottom? 2. Top is smaller than bottom, then you are y equals 0. Questions on how to find vertical or horizontal asymptotes? We're clear on the difference between what we did last night, points of discontinuity. That's when we can cancel things out, right? Break it down to something more simple. Okay. All right. Okay. So we're going to look at a very basic rational function, which remember we talked about this, parent functions. So that we have an idea what that looks like, then later on we can talk about transformations, might be an easier way to look at some things and figure out what's going on. Okay, so we'll look at this using our rules, we'll look at this using transformations, we'll look at it a whole bunch of different ways. Lucas.
Is the vertical asymptote like always the point of discontinuity?
They're not the same thing. Not the same thing. So we said the point of discontinuity last night, we got, it's still, they're both, when you find your undefined values, they will either be a point of discontinuity or an asymptote, but it can't be both. So last night, the difference was we could cancel, when we simplified the equations, we could cancel everything out, right? And so everything on the bottom disappeared when we went to graph our graph, right? That's when you have points of discontinuity. Now what we're looking at is when we cannot cancel out, all right? And then where it is undefined will be an asymptote. Good? Everyone? Okay. So right now we're looking at a basic curve. So let's go down here and find asymptotes for this. First of all, this graph has what? 2 pieces, correct? Right? And it actually has a name. It's called a hyperbola. Not hyperbola, hyperbola. It's not a parabola either, it's parabola. Alright, so asymptotes. If I want to find the asymptote for this, vertical asymptote, I could look at the graph and probably have a pretty good idea. What do you think it is? X or Y. Can't just be 0. X equals 0. But I back that up with my algebra. What am I looking for? I'm looking for where it is undefined, right? It can't be simplified. So it's undefined at 0. So x equals 0 is your vertical asymptote. Okay, so that all fits together. It looks like it on the picture. Looks like it in the graph. And it also makes sense algebraically. All right, horizontal asymptote. If I use my rules, what's the degree of the top? The degree of top is 0. Degree of bottom? 1. So top is less than bottom, which means do I have a horizontal asymptote? Y equals 0. That's going to be my horizontal, which again makes sense in my picture. Good there? What's my domain for this? Zach? all real numbers.
All real numbers, but not equal to 0.
Is it good within there? Akey, range?
Why we took that, all the numbers. But why did not equal 0?
You can also, sometimes you'll see it written like this. X such that X is an element of all real numbers, and I'll do a slash, which means without. And then they use set notation and put the 0 in like this, just so you know what that means. So this is a without. That means without 0, or in other words, 0 is not included. Okay, in case you see that written that way. So far with the basic. All right, what else do they want to know? Zeros? Is that the last thing on here? Are there any zeros? What are zeros? It doesn't have to
Y
cross the
equals
axis.
0.
When y equals 0, right? Answers when y equals 0. Answers for x when y equals 0. Okay, so do you have any zeros? Looking at the graph? No. Looking at the fraction. When does a fraction equal 0? When numerator is 0. Right? And the denominator doesn't? Okay, so if the numerator equals 0 and the denominator doesn't, then you know the whole fraction equals 0. Is there any way this fraction is ever going to have a numerator of 0? No, there's a 1 sitting there. 1 can't become 0. Right? So clearly that can't have any zeros. Are we okay with that? Okay. So you've got an idea what this basic curve looks like, right? You've got a horizontal and a vertical asymptote at 0, and you've got quadrant 1 and quadrant 3 for your graph. Good? All right. What else we got on here? Okay, let's look at this one. Identify the asymptote, domain, range, blah, blah, blah. Okay, look though, be careful, the graph is, or the spaces are about 2s. Okay, so just so you're paying attention. So what do you think? Do we have a vertical asymptote if you're looking at the graph? Yes, where do you think it is? You have to guess. 1 maybe? Right in between, because each box is 2. All right, so how do we figure that out on our own, not looking at the graph? How does my vertical asymptote? What makes it undefined? So x minus 1 equals 0, which means x equals 1. Yep, that matches up with what we thought. Horizontal asymptote. If you had to look at the graph, would you say there is one, and what it would be? 0 maybe? And how would we double check ourselves based off of the equation? Check the degrees, right? Okay, so what's the degree of the top? What's the degree of the bottom? 1. So we have 1 and it is at y equals 0, right? Makes sense? Fits together. They also want the domain. May, what's my domain? Range, Andrew? You good there? Questions, anything? Alright, let's try this one. If you're looking at the graph, does it look like there's a vertical asymptote? Yeah, it looks like there is one for sure, right? Where do you think it is? Looks like it's right on that line, right? Every box is 2, right? So maybe at -2. And if you double check, we're looking good, right? Looks like that would be my vertical asymptote. Are you okay with that? All right, does it look like there's a horizontal asymptote? Looks like it might be at here somewhere. Looks like also 1 maybe, right? Okay, so if I go to check my rule, based off of this, what does it look like the top degree is? 0. What's the bottom degree? 1. What should my asymptote be if the top is 0 and the bottom is 1? 0, but that doesn't make sense with the picture, correct? The reason for that is what? It's being shifted, right? If you think about it as a transformation, it'd be shifting up one. Now, I still want to be able to use my rule. We don't have rules that don't work. So what's the catch on the rules? You have to have one single fraction here. Do we have one single fraction? No. So if I want to use the rule on this, then I have to get a what? Common denominator. Right? All that stuff we practiced. Then my rule should be okay. What would my common denominator be? X plus 2. Didn't change anything here, so it's theta 3. Multiply top and bottom by x plus 2. Common denominator x plus 2. Add my numerators. X plus 5, right? Now I go to do my rule. What's the degree of the top? 1. What's the degree of the bottom? 1. The degrees are the same. What do I do to find my horizontal asymptote? Lead coefficients. What's the lead coefficient of this one? 1. What's the lead coefficient of the bottom? 1. So y equals 1 is the horizontal asymptote. Yep.
So, you can't suppose,
We're going to do it by transformations too.
okay.
Yep, so hang on to that thought, yep. So we're gonna do a little of both, and I would say, depending on how tricky some of these are, like this one definitely is an easy one to do by transformations. Okay, but depending on whether transformations are helpful, but definitely with the verticals it's helpful. Alright, questions? What do we need? Still domain? John, what's my domain? Circle? Range, Haley?
Y such that y is the elements of all real numbers, y is not equal to 1.
We're set, domain, range, finding our horizontal, vertical, even if we gotta combine. Okay. Quick review of transformations here, right? You've got an x minus h on the bottom. What kind of transformation is that? Horizontal what? Shift, right? Horizontal, and it could be right or left. It depends on what. If I wanted to go to the right, what do I know about h? Okay, but h could be a negative, right? Okay, so horizontal shift moves right if what about h? What's going to make it move right? If h is what? Positive, right? And it would move left if h was negative. Because if h was negative, then this would become x plus whatever the number is, right? Okay, what's k doing for us in terms of transformation? Vertical shift. And if k is positive, what's the graph doing? Goes up. K is negative, goes down. What's this number on top doing? A dilating, right? It is a vertical shift or a stretch or compress. If A is greater than 1, what's it doing? Stretch. Because your distance, your y values are, let's say, doubling, right? It's going up twice as fast. If A is between 0 and 1, because if it's negative, you're really dealing with that reflection. So that negative is just a reflection. So if your A value is between 0 and 1, then it is a compression. The y value is shrinking. Alright, so, and we gotta know what that basic parent function looks like, right? That was the one we did, y equals 1 over x. Let's sketch. Asymptotes are where for this one? Uh-oh. 0 and 0, right? And the graph quickly. There's our parent function, 0 and 0. Okay, so then what transformations are going on here? Order matters. Who thinks they're vicious? Order matters. Horizontal shift. Horizontal shift, what direction? Left. 3. Right? Horizontal shift, left 3. So let's think. If I took this entire graph right here, and I shifted it left 3, what's changing? The asymptote, right? Which one? Are they both changing?
No.
The vertical is changing, right? So your vertical asymptote is shifting left 3 with you. Is the horizontal changing? No. Okay, so I know based off of this, my vertical asymptote is now x equals -3. Now, could I also just check by my rules and find out where it's undefined and say it's undefined at -3? Yes. That should match up, correct? Okay, and it does. All right, what does this 8 do? So it's a what? Don't call it dilation. It's a, what kind of stretch? Vertical stretch. So that means if I had a y value, let's say at 2, it's now at 16, right? So it just went up quicker, okay? Is that going to change any of my asymptotes, affect any of my asymptotes? No. It's still going to approach it, right? It's not going to change any of my asymptotes. So my vertical's here. What's my horizontal asymptote? What's my horizontal asymptote? It hasn't changed, correct? So what is it? Y equals 0. There's my horizontal. Am I losing people or no? Yeah? Where did I lose it? Horizontal. So here's my original parent function. Remember, we're back to this one. You're comparing it to this.
Right.
And what did I do? I shifted it over. Didn't affect this. And then all I did was take this and stretch it a little bit. But it's not, it still can't ever hit here, right? And it still can't ever hit here. So it just is going to go up steeper quicker.
What can it hit? It can hit y equals 0 now.
It can cross over as it gets steeper,
Yeah.
correct? But it's still never going to do anything here. So it's going to get steep here, it's going to get steep there, shift it over, right?
Okay.
You guys kind of see what I'm saying? This is 3, okay? And it might just be steeper. But it's still going to approach, okay? And it's still never going to cross this x-axis. You all right with that? So your horizontal's not changing. What about your domain and range? What's my domain of this? X is all real numbers except -3. Your range? Such that y is all real numbers except y still doesn't equal 0, just like the parent function. You okay with that? All right, how about this one? What are our transformations that we're dealing with? Horizontal shift again, right? Horizontal shift, right, 7. Then what?
I'd make the vertical.
Vertical. What? Not a shift. Hungry snakes are vicious. Order. Vertical stretch.
You have to even include that for the
It doesn't affect it, but yes, you're still talking about the transformations that are occurring. Okay, and the third transformation, which does impact things, right, which is what? Vertical shift. Down 8. Really the ones that matter in terms of your asymptote are which ones? Horizontal shifts and vertical shifts, right? Okay, so if I take the entire graph and I shift it to the right 7, okay, which asymptote is affected? The vertical. So now what is my vertical asymptote? 7. Well, not 7, but what? And horizontal asymptote, what happened? Went down. So it's now at y equals -8. Now, you have to follow what I'm saying here in terms of, like, if all I had to do was graph it? No, because you can use your rules to get it. You just have to make this become a one fraction to use your rules to find your horizontal. I think it's a little easier to think of it as shifting it down 8, right, than it is to try to get your common denominator and do all that stuff. You guys with me? Okay, so a little combination of both. What's our domain here? Selena, what's my domain? Seven. Range, max.
X, or Y is down there, except for area.
Yep.
There's no horizontal asymptote.
If you're using rule, is that what you're asking me? Or using transformation? If you're using rule, I have to get a common denominator. And then I could say take the degree of the top and the degree of the bottom. How did I know it this way? Because I understood that transformation, if I took the entire graph, the parent function, this is my parent function, and I shifted it down 8, that asymptote is going to move down to 8.
So the last one, I'll make the just up 1 because it was pessimistic.
Correct. Anything else? We didn't do it by transformations on that one, right? Okay. So, find the zeros, vertical asymptotes, horizontal, and then graph. We're not using our graphing calculator right now. Okay, we should be able to get a really good idea what this looks like way before we need our graphing calculator. So what do I got for a vertical asymptote? How am I going to find it? Undefined, right? Where is this going to be undefined? X equals 2, right? Okay, so then I go over to my graph, right? At x equals 2, and I put a little dashed line to represent my asymptote. Okay, there's my vertical asymptote. Horizontal asymptote, how am I going to find that? So I got to do my rules, right? So degree of top is what? 0. Degree of the bottom, 1. So do I have a horizontal asymptote? Top is smaller than bottom. Yes. So y equals 0. It's going to be my horizontal. Put a little dashed line on y equals 0. Vertical tip. Find any zeros. Your zeros are, right, when y is equal to 0. So 0 equals -4 over x minus 2. Again, what did we talk about with fractions? What really matters when you're looking for zeros? The top, correct? Can the top of this fraction ever equal 0? No, this makes no sense, correct? That can never happen. You guys agree with that? And on top of it, how also do I know? I got an asymptote sitting here, don't I? So I know it can't be defined there. Okay? There are no zeros. Alright, so just think here for a second. Don't use your graphing calculator right now. We can do this without a graphing calculator. Let's find an easy one. Let's find f of 0. Right? F of 0. So what do I want to do? Oh.
Didn't you just say there's no F?
No, I didn't, I said when y is equal to 0. Right now I want f of 0. What's f of 0? That's when x is 0, right? So if I fill in 0 for x right here, you want an easy one to do? What are we getting? 2. Right? So 0, 2 is a point on this graph, correct? Right? Alright, let's find one more. How about 1? If I fill in 1 here. F of 1. So negative 4 over 1 minus 2. That's going to give me what? Negative 1, so positive 4. So 1 is up at 4. Okay, so listen for a second. This is an asymptote and this is an asymptote. Doesn't that tell me that the graph, part of the graph is over here in this area over here? Because it's going to approach this and it's going to approach that. Do you guys agree? So can I get a pretty good idea? I mean, I could get one more point over here to get a really good idea, but doesn't it have to look something like that? Because it's got to approach this horizontal, it's got to approach this vertical, and I already got 2 points in that area. Good there? Okay, so now I want to figure out what's going on over here. Okay, so an original parent function was like first quadrant, third quadrant type idea, right? Now we've shifted. So how about f of 4? Let's try that one. F of 4. What do we get for f of 4? Negative 2. Okay, so out of 4, I'm down at negative 2. Okay, so what does that tell me about that entire graph? Isn't it like in here? Right? Approaching this side and approaching that side? If I can find one more, I can go to my graphing calculator and get like 2 more points. But I already have a pretty good idea what it's going to look like, correct? Okay, so generally speaking, and really quick, you guys can find a couple more points in your graphing calculator. But that's basically what it's going to look like when you type it in. You guys with me on that? Yep.
Is it always gonna be like
It's a hyperbola. Yep.
unexpected?
Okay. Not, I mean, for a basic one, it's a hyperbola, like our basic one. Not every single one. We looked at that one on the front where it had like a little parabola looking thing, and then, you know what I mean? Like not every single one, but your basic ones. Yep. What's what?
What's the nomenclature? Nomenclature of hyperbola.
Hyperbola?
Yes.
You can look that up. Okay. Let's try one more real quick. You want to graph this one. What things can we find quickly? Undefined. Vertical asymptote, right? And I know, like I could factor the top of this, it would be 2 times 2x plus 1, but is anything still going to cancel out if I factor? No, so I know it's an asymptote, not a point of discontinuity. Okay, so x equals 1. How about horizontal? What am I looking for? Degree of top, degree of bottom. What's the degree of the top?
1.
Degree of bottom? 1. So what do I look at? Lead coefficients, which are 4 and 1. So y equals 4. 4 over 1. Alright, so I put those in at x equals 1. I have an asymptote at 4. I have one. Zeros. Define zeros. I want to know where this fraction equals 0. And again, do I really care about the bottom? No, all I care, I mean, if you want to cross multiply, it's going to cancel out, right? So really it's just 0 equals 4x plus 2. Subtract 2. So at negative 1/2, it's crossing the x-axis, right? So at negative 1/2, 0, it's going to cross the x-axis. So right there is a point in the graph. So I know it's going to look something over here, right? But I need a couple more points to get a good idea. Okay, so what else could I try over here? How about 0? 0 is a quick one to plug in, right? F of 0, what are we getting? Negative 2. Alright, so I already know one step here. Alright, how about at, I don't know, one more. Negative 2. F of negative 2 is going to be negative 8 plus 2. Negative 3 on the bottom. Nope, that's a negative 6, 3, 2. Positive 2. Alright, so I got that piece pretty good. I got a couple points, right? I put in like 3 points and got that. Now I need to know what's going on over here, correct? So how about I fill in 2? What's f of positive 2 gonna give me? That would be 8 plus 2 over 1, so 10. Agree with me there? Again, this is where you put in your calculator. 8, 9, 10, of course that's not there. But we know it's gonna be up here,
Yeah.
right? You agree with that? Do we have it typed in already? F of 3. 1497. 2, 3, 4, 5, 6, 7, 8.